Hi, I hope you're doing great. This video is a continuation from the last video that I did, which is called Introduction to Derivatives. So, a few days ago I was asked for help in solving this problem, which says that the function d of p equals 100 over the square root of p, and you must find the derivative of 0.500 and also the equation of the tangent line to d at p equals 500. So let's start. Okay, so the first thing we must do is write the limit, which I taught you before, which is the limit as h approaches 0 of d p plus h minus d of p over h. Okay, this is a limit that I taught you before, instead that I'm using d rather than the f because the name of the function is d, so that's why. Okay, so then simply substitute your function into each of these things. Okay, so that will be the limit as h approaches 0 of 100 over the square root of p plus h minus the square root of 100 over the square root of p over h. Notice something, I wrote p plus h inside the square root because that is the input of this function. Okay, so let's continue. Now what we must do is to eliminate these fractions by adding them. So that will be the limit as h approaches 0. Remember to use, this is really helpful, use the little smile technique. Basically you multiply this by this, plus or minus depending on the sign, in this case it's minus, this times this, over the product of these two things. Okay, so that will give us 100 times the square root of p minus 100 times the square root of p plus h over the square root of p times the square root of p plus h, everything over h. Okay, now let's eliminate this fraction by dividing it with the little ear process. So basically what is going on here is that this h will be moved right here, just like this. Okay, so that will be the limit of h approaching to 0 of the same numerator, because you're multiplying by 1 and that doesn't make any changes, 100 p plus h, and over, you multiply this h by this, which is h square root of p times the square root of p plus h. Now notice that this 100 is in both of our monomials here, so it is here and it is here. So something we can do is factor that 100 out and get it out of our limit, just to make things easier. Okay, so that will simply be 100 times the limit as h approaches 0 of the square root of p plus h minus the square root, I think it was the square root of p minus the square root of p plus h, yeah, that was right, over the same denominator, which was h square root of p times square root of p plus h. Okay, so now we can try and test this to see if it's undefined or not. So let's try it out. Simply substitute for every h as 0. Okay, so that would simply give us square root of p minus the square root of p plus 0 over 0, and it really doesn't matter what 0 is multiplying because you know that it will give us 0. Okay, but let's copy it right, p square root of p plus 0. Okay, so now if you have the square root of p minus the square root of p, that is 0, and as I said before, 0 by anything is 0, so yes, it is undefined. That means that we must apply one of the strategies taught before in order to calculate our limit. So one of the strategies is to rationalize. Remember, when you rationalize, you multiply by the conjugate. In this case, the conjugate of this will be the same square root of p. Instead of the minus, you add you put an adding plus sign, and then the square root of p plus h. So let's do that. So that'll be 100 times the limit as h approaches 0 of the same thing here, which is p minus square root of p plus h over h square root of p square root of p plus h. And as I said before, you multiply by the conjugate, which is the square root of p plus square root of p plus h over square root of p plus square root of p plus h. Okay? Now, when you multiply by the conjugate, basically what you're doing is applying the difference of squares. See here that your answer will be square root of p squared minus square root of p plus h squared. We could do the whole multiplication, but to make things faster or simply to clear things up, let's just apply the thing that I told you, the difference of squares. So that will be 100 limit as h approaches 0, and that will be the square root of p squared minus the square root of p plus h squared over h square root of p square root of p plus h times the square root of p plus the square root of p plus h. Okay, if you have issues with this and you need a video about rationalizing, just tell me, okay? So now that would simply be equal to 100, the limit as h approaches 0, square root of p squared would simply be p minus square root of p plus h is p plus h over h square root of p plus h. I simply copy the denominator over again and over again, okay? So that will be it. And now notice something here. Here you have p minus h because you're multiplying this negative by everything that's inside. So simply you'll be left off with negative h over this same denominator, okay? And here you can finally cancel out this h with this h. So you will be left off with the same thing, 100 limit as h approaches 0, but now we will have a negative 1 on the top, on the numerator, and the same denominator, but without our h. So it will be this p plus h, okay? And now we can finally test to see if this is undefined or if it isn't. So let's test this out. So that will be 100 times negative 1 over square root of p times the square root of p plus 0 times the square root of p plus the square root of p plus 0, okay? So that is, here notice that basically you're having square root of p times square root of p. So that is simply p. Basically, as I said before, you're multiplying two square roots, so just eliminate that square root and copy what's inside, which is p, okay? And then you multiply that by square root of p plus square root of p, that will be 2 square root of p. And that is equal then to 100 over 2 times negative 1, that's negative 50. And here underneath you have p basically to the 1 to the first power times the square root of p. So remember that the square root of p is basically p to the 1/2, okay? And then remember the law of exponents, you simply add up the exponents, and that will be p to the 3 over 2, okay? And if you wish to move that to the numerator, which is the most convenient thing to do, then that will be negative 50 p to the negative 3 over 2. If you have troubles with the law of exponents as well, you can tell me and I'll do a video about that. So knowing your derivative of the function, which is what we just discovered, we can solve the first part of our problem, which is finding the derivative at 0.500. So simply substitute your p by 500. So it'll be negative 50 times 500 to the negative 3 over 2, which is approximately, this sign means approximately, negative 0.00447, and that is the answer to the first part of your problem. Now solving for part B of our problem, which states find the equation of the tangent line to D at P equals 500. For that, you need the equation of a line, which is y equals mx plus b. For that, you need the slope, which we already have it. The slope is simply the derivative of 0.500, which is negative 0.00447. So let's copy that. 0.0447, okay? And you need point y and point x. Point x, the problem already gives it to you, which is 500. And I know here it looks for point P, but it's just the way it is written or the way that it is expressed in this problem, okay? So that will be your point x, which is 500. Now for P, that will simply be dx or dp, which is d of 500. For that, simply use your function, which is 100 over the square root of p, in this case 500. And that should give you something around 4.47, okay? So you know that your point y is 4.47. Now you need your y-intercept. For that, simply plug in those values into your formula, which is 4.47 equals negative 0.00447 times 500 plus b. And that will give you a value of b of 6.707, okay? Which is like an approximate value, okay? So then simply copy again your formula using all of the new variables. So that will be y equals negative 0.00447 x plus 6.707, and that is the answer to part B of the problem.